Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is Vector Operations Review. This is the third video on the review. In the last two videos, we have covered the scalar multiplication and the basic operations and the basic concepts in the vector. Now we are going to concentrate on the unit vector and vectors in rectangular plane and vector components in the terms of magnitude and direction. There we will be using some trigonometric concepts also. A vector which has a length 1 is called as unit vector. So let's find the unit vector in the direction of v. In addition to finding a vector's component, it is also useful in solving problems to find a vector in the same direction as the given vector, but it should be of the magnitude 1. Magnitude means the length. We call a vector with a magnitude of 1 a unit vector. We can preserve the direction of the original vector while simplifying the calculations. Unit vectors are also defined in terms of components. The horizontal unit vector is written as this one, 1, 0, and it is directed along the positive horizontal axis. The vertical unit vector is written as j, 0, 1, and it is directed along the positive vertical axis, not the below one or left one, only the positive things. In the video unit vectors, we discussed the formula to find the unit vector, and we also discussed how to find the vectors that are not unit vectors. Okay, here we are going to review that one now. If v vector is a non-zero vector, we were using this symbol, a hat over that. So the formula to find the unit vector is v vector over magnitude of v. This is called the unit vector in the direction of v. Any vector divided by its magnitude is a unit vector. Notice that magnitude is always a scalar, and dividing by a scalar is the same thing that we do in the multiplication by a reciprocal of a scalar. Okay. So let's see one example in finding the unit vector in the direction of v. Here is the example. Find a unit vector in the same direction as v, negative 5, 12. First, we will find the magnitude, and then we can divide each component of v by the magnitude of the magnitude which gives the unit vector in the same direction. So this one is 25, 144. So sum would be 169. Square root of 169 is 13. Now divide each of the component by this magnitude of v13. This is the component form. So you can also write this using I and j. Hope you are clear with the method. So after finding the answer, you can also verify that the magnitude of the unit vector is equal to 1. So magnitude of this one, negative 5 over 13i plus 12j over 13. So you can find it by using the square root formula. Square root of square of this one and square of this one. So that would be, so this would become 25 over 169 plus 144 over 169. So that is 169 over 169. So square root of 1 is 1. So it is always good to verify that the magnitude of the unit vector is equal to 1 or not. So the vector u equal to negative 5 over 13i plus 12 over 13j is the unit vector in the same direction as the original one, negative 5, 12. Hope you're clear with this example. Okay, now let us see how to perform operations with the vectors in terms of I and j. So far we have investigated the basics of vectors like magnitude and direction, vector addition and subtraction. In the last two videos also, review videos, scalar multiplication, components of vectors, and the representation of vectors geometrically, the geometrical view. Now that we are familiar with the general strategies used in working with vectors, we will represent vectors in rectangular coordinates in terms of I and j. So we are going to see how to represent the vectors in rectangular plane. Consider vector v, which has the initial point and a terminal point. Let that initial point be p and terminal point be q. Let v vector be written as x2 minus x1i plus y2 minus y1j. The position vector from 0, 0, the origin, to any point a, b, where this is equal to a and this y2 minus y1 should be equal to b. So this can be written as same thing. I'm just going to replace x2 minus x1 by a, y2 minus y1 by b. So this vector sum is called as a linear combination of the vectors I and j. You should write a line segment here. Its magnitude will be given as square root of a square plus b square. You can also draw it in the geometrical view. You'll be just getting a right triangle AI BJ, where this one would be the hypotenuse would be AI plus BJ. I'm going to take a very simple example and explain you how to write a vector in terms of I and j. Here is the example. Given a vector v with the initial point p equal to 2, negative 6 and the terminal point negative 6, 6. Let's write the vectors in terms of I and j vector. Let's begin by writing the general form of the vector, which we just discussed. And then we can replace the coordinates with the given values. So this is the general form. Let this be x1. Okay, you can just plug in these values. x2, y2, x1, y1. So by plugging in, I get negative 6 minus 2, 6 minus of negative 6. So negative 8i plus 12j. Hope you're clear with this example. So you have to do the same thing when you're asked question in writing a vector in terms of I and j using an initial and terminal point. An initial point will be given and a terminal point will be given. You have to just use the standard form and plug in the values given in the corresponding coordinates placed, and then simplify using the algebraic calculation. You should be careful when you get a negative sign in the terminal and end point, because already we have a negative sign in the standard form too. Hope you're clear with this concept. Okay, now let's see how to perform operations on vector in terms of I and j. When vectors are written in terms of I and j, we carry out addition, subtraction and the scalar multiplication, the basic operations, by performing operations on the corresponding components. So let's see addition and subtraction of vectors in a rectangular coordinate form. Please consider two vectors v and u, ai plus bj and ci plus dj. So what would be the addition and subtraction? So we have just taken rectangular coordinates. V plus u and v minus u will be. So as I just mentioned, we are performing the operations on the corresponding components. A plus b here, a minus c here. Okay, let me take one example and show you how to find the sum of the vectors. And difference would be the same thing. You'll be just changing the sign. So here is an example. Just add the components 2, 4 and negative 3 plus 5. So I'll get 6 and 2. We have completed the review of most of the topics. Now we are going to move to calculating the component form of a vector. We have seen how to draw vectors according to their initial and terminal points, and also we saw how to find the position vector. We have also examined notation for vectors that are drawn specifically in the Cartesian coordinate plane using I and j. For any of these vectors, we can calculate the magnitude also. Now we want to combine the key points and look further at the ideas of the magnitude and direction. Calculating direction follows the same straightforward process we use for the polar coordinates. So in finding the direction of the vector, by finding the angle to the horizontal, we do this by using the basic trigonometric identities. But we are going to use magnitude of v replaced by r there. Okay, so these are the vector components in terms of magnitude and direction. So consider a position vector x comma y in the direction angle theta. This is this type of parenthesis. So cos theta is x over magnitude of v and sin theta is y times magnitude of v. You can just rewrite both the things in terms of x and y over v. So x should be written as cos theta times v, y should be written as sin theta times v. Plug in x and y here. So this is the component form, and the magnitude can be expressed as the square root of x square plus y square. So this is the basic for the component form of a vector. Let me take one example and explain how to write a vector in terms of the magnitude and direction. Here is the example question. Write a vector with a length 7 at an angle of 135 degrees to the positive axis in terms of magnitude and direction. So we can use the conversion formulas for x and y. So x is nothing but magnitude of v cos theta I, and for y magnitude of v sin theta j. So we find that just plug in the theta given here. Theta is the angle 135 and the vector is the length. So the magnitude is given. Magnitude and length both are same, no? So replace magnitude of v by 7 and theta by 135. So we will get, so this would become negative 7 root 2 over 2, and I'll be getting a positive thing here. So the vector in terms of I and j can be written as 7 cos, okay, I can just use the answer directly here. So that's it for this example. Hope the concepts are very easy. Okay. Now next topic is dot product of any two vector. As we have seen, multiplying a vector by a number is called a scalar multiplication. If we multiply a vector by a vector, there are two possibilities. First possibility is dot product, second possibility is cross product. Okay, I think you can refer the videos for both dot product and cross product. We have discussed it detailedly in those videos. For more details, you can refer those videos. Yeah, we have covered all the topics under the vector operations, the manipulations of the vector algebra. In case if you get any query regarding this, you can let me know. See you in the next video.